Hi everyone, welcome back to my channel. Welcome to another video. Today we're going to design the second part of the Tetris Python game. I'm building it using object-oriented programming in Python, so if you haven't watched the first part of this series, then I highly recommend you do. If you're new here, my name is Jackie and I'm a self-taught software engineer with a background in mechanical and aerospace engineering, and I currently work at Prime Video in London. Today I want to wrap up the game, so what I'm going to focus on is collision detection between the tiles, building the ground, detecting rows which are complete, deleting those rows and cascading whatever is on top of those rows down. And I want to add a score counter as well. So without further ado, let's get started. I made myself an iced coffee because it's a really hot day today. Just as a recap, this is what we have currently. We have a board class. This class draws our gaming board and it also creates a random tile at the beginning of the game. It assigns a shape to it and a color, and it draws this tile on the board. We have a tile class. The tiles are always represented in a 4x4 matrix, and the pixels which correspond to the tile, I represent them by coordinates within this 4x4 matrix. We have a render function which renders our tile. We have a function to get the coordinates of it. We have a function to get the color. And we have two methods which rotate and move the tile on our board. Then we have a shape class. The shape class contains the rotation at which the tile is, and it also has a method which returns the matrix associated to the tile with the offset after the movement. And then we have a method which generates all of our Tetris shapes and it keeps them in memory. And we have the same one for the colors. And then we have a Tetris class, which is where we manage our game. We have a run method, which lets us run the game. This run method is listening in on the keystrokes so that we know what to do when we press certain keys. It draws our pieces on it and it makes the pieces fall at a certain speed. And it renders everything which we have on our game on the screen. This is the current state of the game. We have a tile which is randomly generated and it falls down, and we can rotate it and make it come down faster. And that's it. So I'm going to start by creating a new class for my collision detection. Actually, I'm going to rename this to collision detector instead of collision detection, since this is a class. And since I want to check collision between the tiles and the ground, I'm going to have to pass in my ground. I already knew from the beginning that I wanted the ground to be a class, but I haven't created that yet. I will pass it in here and then I will go and create the ground class. I will define my ground the same way that I define the board. I'm going to use a certain height and a certain width, and I'm going to create a matrix of zeros with those sizes so that I can represent the ground. So I'm actually going to reuse this. As I mentioned, I think that every time my tile is about to move or to rotate, I need to check whether it will interact with the border or if it will be hitting the ground. And as I said, the ground will be a matrix of coordinates of where the ground is located. So practically speaking, what I want to do is, in these two methods, the move and the rotate method, I want to add an additional check of like, is collision. And this will take in, and this will call a method from my collision detector, which will check whether a collision is imminent in the next move. I want to have a method called collision. No, I can just call it check. And so take in the matrix of the tile and the new movement from the translation, so the dx and the dy. I might have to do it differently for the rotation, but I'm going to start with the normal translation movement first. Collision equals, which I'm going to have to pass in here now. So I pass this into my tile class, and then I call it here, dot check. Tile matrix, dx and dy. I'm still not sure yet what I want this collision to look like. Maybe I'll create an enum for it. First I want to check collision with the game board itself. don't remember how to create an enum in Python. So I'm gonna assume that I can have a collision on the right, on the left, and on the ground, or I can have no collision. If the maximum coordinate in my coordinates array on the columns is higher than the board height, then that means that I would be colliding with the ground. So I'm going to return a ground collision, bottom, if. Okay, so I think I have the collision with the board. I basically checked that the coordinates are within the range of the board. So I checked that the lowest coordinate doesn't go beyond the height or that it doesn't go beyond the width. And I returned the type of collision that it would correspond to if it were to go beyond those limits. And if it doesn't go beyond any of the limits, then I return none. I actually don't need the delta x and the delta y because I'm already using the updated tile coordinates. Now I need to check whether the collision is happening or not, and if it isn't happening, then I will move my piece. If there is no collision, then I execute the tile move. Now I just want to take a moment to thank the sponsor of this portion of the video, setapp. As someone who's always looking for ways to simplify my workflows, I was really thrilled when I discovered setapp. Setapp is definitely the best place to get apps for MacBook and iPhone users. In one single subscription, you can get access to hundreds of high-quality apps, which will help you in increasing your productivity, simplifying your workflows, and in general just making your life easier. I've been using setapp for a while and already have my favorite apps. With setapp, I manage my time and tasks using the session apps, and I sometimes scan and optimize my Mac using the Clean My Mac X app. This is really useful if you have a lot of junk on your MacBook and you need to clean it up. I also like this app called Side Notes, which I use to write down ideas in my daily to-do list, and it just lives on the side of my desktop. There's also a dedicated app to downloading YouTube videos, which is great, and I use the Bartender app to help me keep my menu bar organized. And the best part is that you can get all of these very powerful tools with one single cost-effective subscription. So yeah, if you want to give your productivity a boost, I definitely recommend setapp, and you can try it out with the 7-day free trial. You can check out the link in the description on how to access it. So now I'm gonna work on the ground. I still need to do another collision detection with the ground, but before I do that, I need to think of a way to merge my tile to the ground. Basically, once the tile reaches the bottom of the screen, I want to add it to the ground and stop moving it, like let it just rest there and stay there. I think I'm gonna create a method called merge for that. Okay. Let's try this out. Oh, I see. I forgot to pass in the collision detector. I'm gonna pass it into the boards. Actually, do I need to pass it in? Maybe I don't need to pass in the collision detector into the boards. Maybe I can just initiate it here. This way it's easier because I get access to the board and I can just pass in the whole class and then pass in the ground, and this way I can initiate the ground with the width and the height of the board. Debugging. Let's see if it stops on the ground. Nice. It's not going past the ground. Oh. I can, however, still move it side to side. I guess I need to find a way to lock the piece in. That is locked and set it as false. I only want to lock it if the collision is at the bottom. if it's in connection to the ground. Every time I update the boards and I either create a tile or move my current tile, instead of moving it on the timer speed, I'm going to create another method which will check whether the tile is locked, and if it is, it won't move it and it will instead merge it to the ground. I'm going to call it drop tile. So I'm going to return whether the tile is locked after executing the move function. So in my method to drop the tile, I first move the tile and I check whether it is locked by moving it. If it is locked, then I want to merge it to my ground and I want to generate a new tile at the beginning of the game. And if it's not locked, then I'm not going to do anything because the game will just keep going and I will just keep moving my tile. I also need to add the lock to the rotation, so I can't rotate the tile once it's at the bottom. I'm going to rename this just for consistency. Okay, this way I'm also locking in the rotation, similarly to how I'm doing it for the translation movements. Let's test this. The rotation and translation are still working. Oh god, something's not quite right. Okay, this is not working. Oh well. Let's try to debug this. Okay. So we were always seeing the initial matrix, which was the matrix at the beginning of the game, which was empty. So I updated the board matrix to be the maximum between the board matrix and the ground matrix. And because we are always depositing tiles on the ground, usually the ground matrix will always be higher than the board matrix, so it will update itself. And now we can see the ground rendering on the screen. Now it's stopping there, I can't move it, and now we have a new tile coming. So I think this is working. It also doesn't go beyond the borders. Nice. Now I need to check my collision with the ground, because for certain pieces, if I try to lay them, if I not try to put this piece on top of the other, it will go through it, I'm pretty sure. Yes, because we haven't done the check with the ground itself. We are only checking the borders of our game board, so I'm going to do that now. On my collision detector, I need to create another method to check for collisions with the ground. Check the ground. And I'm going to refactor this and call this check boards, so that I can have a parent method which calls all of the checks that I need to do. I'll just do this because I'm doing something. I think I need to keep a list of the coordinates which I'm adding to the grounds. I will start appending it when I merge tiles onto my ground. Append. I want to append the position. Oops. Oh, I need to know how much I'm walking though. I need to know the translation movement here, because if I go down one more or to the side, it could hit one of the tiles. So I need to know when a rotation collision can happen as well. I'm gonna add it to my enum. And then if there is no translation movement, but the coordinates between the ground and the tile are the same, then I know that it's a rotation collision. Now I'm going to update my method to reflect this. So I need to do a few different checks. I need to do the board check and the ground check. And I do need to pass this in here. If it's rotation, it's 0, 0. And over here, I'm going to pass in the x and the y. So this is a board collision. This is the ground collision. I mean, we don't need to check the ground collision if we already felt a board collision, I guess. So if board collision is not known, return a board collision. Otherwise, we check for the ground collision and we return that. Yay! Nice. Let's try to put it on top. Moment of truth. Oh no! It's not working. Ugh, this is all messed up. Okay, let's go. Let's try to figure this out. Okay, small wins. I did figure out why it was going to the side in the wrong. It was kind of like going to the left side, and it's because I had it here as the tile coordinates position being less than 0, but it actually should be equal or less. Now it doesn't go to the sides anymore. I got this plushie for my birthday. It's a jelly cat. Since I spent my birthday in Vienna this year, I named him Ziggy after Sigmund Freud. I thought it would be fitting since he will be living on my desk and I very often need therapy while I'm working. Okay, so I'm not sure what I did. I just refactored this. It is working now. My pieces are detecting the ground, and the ground is rendering correctly, and we can't move to the sides. What we have left to check now is to remove completed rows. I'll probably add that logic to the ground class. I left a to-do note here earlier because I want to now check for completed rows and return an update on the score with the row check, which tells me how many rows were deleted. For example, let's say that for every row that was deleted, I will increase the score by 1. So I'm going to create a method for that in the ground class. And I'm going to call it expire rows. Row count is 0, and we need to count how many rows are completed in our matrix. So this will count how many rows are completed, but I also want to make these rows disappear. Cascade rows. So I'm going to create a separate method for that. I'm going to call it cascade method. Okay, so for the row elimination, what I'm thinking is we need to loop through all the tiles that we have in our ground, and we need to check for completed rows. The check for completed rows can be done by verifying that certain rows in the matrix do not have zeros present in them. However, every time we loop through a row and we eliminate it, we need to cascade down the rows which are on top, and then we need to loop through it again, because it might be that a new row gets formed when you cascade down the upper row or the upper rows. So because of that, it's important that we loop through the ground from the top to bottom and not from the bottom to the top, because we need to take into account what happens when we cascade the rows. And if we go from the bottom to the top, we can't do it as easily, I think. Actually, we can still do it the same way. The problem is it won't be as efficient because we will have to move more. I initiate a counter for my row count and I loop through the height of my matrix. And while the numbers in each of the rows of my matrix, which represents my ground, is different from 0, then I cascade these rows and I increase the counter of my row count by 1. And in the end, I return my row counter. I think a good way to cascade the rows down is first to create an array which enumerates the rows we have in our ground, and then we reverse this array so that we start from the bottom up, from the last row onwards. And for every row index, which we just created in this row array, we can check that for this row, or actually we can reassign the row which comes before in the matrix to the row which is just above. So we do sort of like a row reassignment in here, and we keep doing this for every row in our array. And at the end, we need to reset the first row. And now I need to update my methods over here so that we can increase the score. Let's see if this works. Let's play until we get a row. Oh my god, moment of truth. Oh my god. Oopsie. Oh. Oh, I was doing this wrong. It's H plus 1. Oh, I was reassigning the earlier row to the row, but it's actually the lower row should be reassigned to the upper row. So I need to increase in Y because my reference point for Y goes down. Oh my god. Huh. Let's see. It worked! Oh my god, that's so cool! Yay! Let's see if we can do... Oh my god. Oh, there's a bug here. Let's... Oh, I think I need to update the ground somehow. I think the ground is not being updated. My coordinates are not being updated because I do update the matrix but not the coordinates, so I need to do this. So I basically wipe clean the coordinates array and then put everything back in according to the new matrix. And then I'll recompute it here. Actually, I only need to recompute if the row count is different from 0. Oh, nice. Okay, and now it shouldn't have a problem with accessing the last row that we just deleted. Yes! Let's see if we can remove 2 rows at the same time. Let's see if that will work. Oh! And the score is updating as well. Oh my god, almost committed a big error because of my sneeze. I think this is all I have for you guys for this video. As always, the code will be down below in the description, so you can clone it from GitHub and you can use it as a reference point if you're building your own game, or you can even build on top of mine and improve it if you want. If you guys decide to build Tetris, I would love for you to tag me because I love seeing you guys getting motivated by my videos to do something like this. As always, thank you so much for watching, and thank you again to Setapp for sponsoring a portion of this video, and I will see you in the next one. Bye!